I'd like to take a minute just to discuss a topic known as the quadratic approximation. If you look at this long equilibrium problem, it's the first example we give where when you technically go to solve the problem right there, you end up with solving for x being messy, and it would require a quadratic equation. In AP Chemistry, they do not do quadratic equation solutions. They simply make the approximation that x is very small, and they go ahead and solve it without using the minus x part. This part stays there, right? And so that's how we solve them. It makes the math a lot easier. Several points I want to make. Number one, if you search this on the web, at least as of 2016, you get a host of different validations for that. You get the 5% rule, which some people hang by, meaning that the value of k is very small, 5%, compared to a. Other people say that the 100k is less than a, which is a little more stringent, which is even if 100 times that thing is less than the concentration of one of the reactants. And I took this one here. With acids and bases, they usually just give you one number, so it's a little easier. Other people just say that k is very, very small, and so we can make this approximation. I mean, 10 to the minus fifth is a very small number. There does seem to be no consensus on this, and if you actually go to the College Board and look at their long list of 160 objectives and why they've eliminated some types of problems, you won't find anything about quadratic approximations or quadratics at all. The word quadratic won't even show up. So there's no real guidance here, except that it seems to be that there's never really been a quadratic solution problem ever asked, and so always eliminated. If you were asked to justify it, use either of those methods, 5%, 100%, and you should be fine. So we always make the quadratic approximation.